All right. Today we begin with unit number 2, trigonometry, which is basically a more intense study of triangles, and it is built on previous concepts, applying the Pythagorean theorem, a squared plus b squared equals c squared, solving problems using properties of similar polygons, and solving problems using ratios. All things that we covered last year. The big here that we're going to look at. The ratio of any two sides remains constant even if the triangle is reduced or enlarged. So if you have a triangle with the short side 3, the middle side 4, and the long side 5, that triangle can be increased to 6, 8, and 10, for instance. Or you can increase it further, or you can reduce it. The angles of the triangle, however, stay the same, which will leave the ratio the same. You can use the ratio of the lengths of two sides to determine the measure of one of the acute angles. You already know the right angle. All of this only applies to right angle triangles, okay? So you know the right angle, and then you can use the length. If you know the length of two of the sides and it's a right angle triangle, you can use that to find the measure. You only know one angle, but the lengths of the sides, a new concept for you. And you can use the length of one side and the measure of an acute angle to determine the length of another side. So if you've got a triangle where you only know the length of one side, but you know what one of the angles is, one of the angles other than the 90-degree angle, you can use that to find the unknown side. And there's some new vocabulary that will pop up as we go through. I won't go through this. This will pop up quickly enough. So, why don't we begin? These worksheets are on the back cabinet. Why don't we begin with a review of Pythagoras? ABC is an isosceles triangle where AB is equal to AC, and they're 12, and BC is 10. So all the way along the bottom here, from B to C, we have 10. So that means each side is 5. And then we have these two sides equal to 12 centimeters each. Now, this is not the best drawing, right? It should, like these sides should be a bit longer. But anyways, I digress. We're looking for the guy in the middle. That's what we're trying to find. So this is the short side, or yeah, it's the short side. 5 would be the middle side. Let's just do our math right along here. A squared plus b squared equals c squared. So we're looking for A, we have b, and we have c equals 12. A squared, 5 times 5 is 25, 12 times 12 is 144. 144 minus 25. 119. $10.9. Whoops, I was supposed to add. My mistake. Cross this out. I know. Never mind, you have to subtract. So then this was apparently this is the middle side. Ugh. Whatever. This diagram is crappy, to say the least. But anyways, we'll go with it. 144 minus 25 is 119. And we'll do the square root of 119 down here. shouldn't have used this diagram, which makes me worry about the rest of the sheet. That it's just going to make things more confusing. Let's skip number 2 and do number 3. This is really intended to be just a refresher of Pythagoras. So a ladder is 8 meters long. It leans against the wall with one end on the ground 6 meters from the wall. So we want us to calculate the height of the windowsill above the ground. That's here. I think this time it really is the short side this time around. Let's hope so. A squared plus B squared equals C squared. We're trying to find A. Never mind. Still just like the other problem, but whatever. We'll move on from it. A squared plus 6 squared equals 8 squared. 6 times 6 is 36. And 8 times 8, 64. (64 minus 36). $5.3. Okay, that one was better, right? Let's take the chance that 2 is going to be all right as well. Okay? This time we're dealing with coordinates. So point A is at 4, 7. That means it's located at 4 across and 7 up. So A is located where X, because if you got X and Y coordinates, the X comes first, right? 4 is X, Y is 7, and X is horizontal. Remember that whole idea? Okay, so A is at 4, 7. Right here. And B is at 16, 12. Now we can use these two ideas to find the lengths of our sides and then use them to find. So where the length here, A is at 4, and if we go across, B is at 16. So between 4 and 16, we have 12, right? So the length of this side is 12. Then we have BC. Going up and down, Y is horizontal, it's at 12. And A over here is at 7. 12 minus 7 is 5. Okay, so now we have our measurements and we can go ahead. A squared plus B squared equals C squared. This time we're trying to find C. So 5 squared plus 12 squared equals C squared. 25. Okay, hoe heb both going steeks mochtijn. 12 squared get the hat, gans aan the end. Add B squared equals 12 squared is 144. And then I'm simply going to do, this is going to be the same answer as the one above. 144 minus 25 is 119, square root 10.9. Okay, that's that. That's the first page of these. So make sure you've got this, and then I want you to try just on your own for some practice. There's 2 more on the other side here. Here we have the short side with the length of 4, the long side with a length of 6. You're trying to find side B. And for this next question here, you want to find the diagonal of this rectangle. Now let me quickly draw you a diagonal here. So there's your diagonal. It's 13 centimeters long, 7 centimeters wide. right? And so to find this guy, right, you would simply do take the 7 as your short side, the 13 as your middle side, and he would become side C. So try these two questions on your own. This is intended as a refresher of previous concepts. Brings us to the end of our first recording for this week. Adios.